So what we're going to look at here is kind of like a revision clock that's designed to help us with answering questions on our human fieldwork investigation that we did. And it's really important to remember in that paper 3, half of it will be on pre-release and half of it will be on fieldwork. A large section of that fieldwork will be on the investigation that you actually did kind of back at the start of year 11. There will be some unseen fieldwork questions there, so you may be asked questions about other people's fieldwork. Maybe given some data that somebody else collected and asked to identify problems with it or ways that you may present it. But a large amount of that knowledge and application of that knowledge will come from what we actually did ourselves. And on top of that, you'll be able to apply what we did. So the first thing you've got to be aware with the revision clocks, if you haven't done one of these before, the idea is you spend 5 minutes revising each section. Actually what happens here is, with the way the fieldwork works, some of those areas might be a bit shorter and might actually involve you doing less revision. First thing we've got to remember is the title of our human fieldwork. You've got to have that at the start of questions asking you about your fieldwork. It may say using or naming an investigation into human geography that you completed or undertook. So you need to know that we were looking at to what extent has the regeneration of Worthing Town Centre been successful. Something along those lines. If you don't get it word for word in the exam, that is not a massive problem, but you do need to get something similar to that. So if you were to say, has the regeneration of Worthing Town been successful? That would still be applicable in the exam. We're then going to move into our first section here, the blue section, okay, which looks at the justification for why we were studying that. So what was the reason for studying that geographical theory? Okay. First, obviously, it comes up in the curriculum, so it's relevant for us to study. But most importantly, we've got to remember that Worthing Town Centre has recently undergone a multi-million-pound regeneration scheme. Okay, the area around Montague Place has been heavily regenerated, and that is in stark contrast to the areas surrounding it, for example, Chapel Road and the Gilbourne Centre, where very little regeneration has taken place since kind of the 1990s. The idea would be that this regeneration would result in an increase in visitor numbers, an increase in income for the town centre. The study therefore aims to see if whether or not this regeneration has been successful in creating a larger number of visitors and therefore a larger range of high quality comparison shops. Moving on to the second section then, we wanted to have a look at the justification of why we were studying where we did. Worthing Town Centre has obviously undergone that regeneration, but it's not the only place to have done so. So why did we choose to do our study there? This is actually relatively straightforward. You've got to remember that Worthing Town Centre is only 3 kilometres away from Durrington High School. Therefore, travel times were very low and travel costs were also kept to a minimum. This is a more than relevant justification in the exam. On top of that, the area was pedestrianised, therefore meaning that risk assessments were pretty low, and you obviously have a familiarity with the area, having lived in Worthing. On top of that, the regenerated area in the town centre is surrounded in all directions by non-regenerated areas. So it was an area that would allow for a very quick and simple comparison of the two locations. We then moved on to looking at the risk assessment. So what were the risks and how did we try to manage or cope with those risks and reduce the hazard posed? Okay. So, most obvious one is obviously vehicles in the town centre and the possibility of being involved in an accident. To avoid this, our risk assessment was to ensure that we used designated crossings, so zebra crossings, pelican crossings, traffic lights and so on, and in as many opportunities as possible, stay within the pedestrianised area of the town centre. This obviously greatly reduced this risk. One of the other things as well is when you're working in a public space like a town centre, you are going to come into contact with a lot of strangers. We refer to this threat as stranger danger. What we did to try and minimise that, if you remember, is that all groups had to stay in a group of at least 3 people whilst doing the work, so that you had kind of a buddy system around you, so that if something happened, one person could stay with that person and the other person could go and get help, and you were all given an emergency contact number of the staff so that you could contact them if necessary. Now, any fieldwork risk assessment would not be complete without considering the possibility of inclement weather. So high rainfall, maybe stormy conditions. You remember we were going in November, so this was a high chance. We were quite fortunate in fact that the weather actually turned out to be very good, but we still had to risk assess that. We had to ensure that we had examples of appropriate clothing, so coats and jackets, in case of it becoming cold. Moving on then, we're going to look at the data that we collected. So, what we looked at first was pedestrian counts. This was quite simply collected. Now, the exam isn't really going to ask you how you collected it. It's going to more ask you why you collected it, what was the reasoning behind collecting that data, or the way that you collected it. But we do need to consider roughly how we did it. So if you remember, we did a point survey. That means we stood in one place and we counted the number of pedestrians that went past us in both directions in a 10-minute interval. We did that once in the regenerated area and once in the non-regenerated area. Okay. Now, why we did that? Okay. If we assume that pedestrians represent customers, the higher the pedestrian count, the higher the footfall in the area. Higher footfalls would indicate that one area is more attractive and to visitors, and therefore it's going to have more customers in the area, okay, resulting in an increase in income. That would indicate that an area is successful, and that would therefore tell us if the regeneration has been successful. You've got to remember, we expected to see a high number of pedestrians in the regenerated area, as that was the whole sort of purpose of that regeneration, to bring in new customers. Now, you maybe get asked to justify your kind of sampling. So we only did a point sample, we only counted for 10 minutes. Okay, we'll come into the problems of this in a second. But the major reason for doing that is simply time constraints and manpower. There isn't that many of us. Okay, we didn't have a huge amount of time as we needed to get to the beach in the afternoon to do our physical field work at low tide. Okay, so counting for 10 minutes gave us a large enough sample size to collect some meaningful data, but also not to spend too long doing so. We then moved on to our next data collection, which was a Shocktide Cam. Again, we did a point survey. Here we did a 360-degree point survey, so we sort of looked 360 degrees all the way around us, and we counted the shops that we could see. We then put these shops into categories by their types. We had eateries, so things like restaurants and cafes, other shops, empty shops, comparison shops. If you remember, comparison shops are your higher order goods, so those things that you won't buy that often, so things like jewellery shops. Okay, and then we had our convenience shops, our things that we might normally have cheaper products in that are going to be bought on a regular basis, like a newsagents. Now again, the justification behind this is quite straightforward, really. The number of shops, particularly the number of comparison goods and eateries, is a clear indicator of whether or not an area is successful. So again, we would expect, if the regeneration of Woburn Town Centre has been successful, to find a larger number of those high order comparison goods shops in the regenerated area. At the same time, an increase in things like other shops that might come under things like betting shops and empty shops would indicate that the regeneration hasn't been successful. We were hoping that we'd find more of these in the non-regenerated area to show that this area is yet to develop because of that lack of regeneration. Again, when it comes to the sampling, 360-degree point survey was simply down to time constraints and manpower, and also it may have been unfair if we'd counted every single shop in the two areas, because the regenerated area is much smaller than the surrounding non-regenerated area. Finally, we looked at environmental quality. Again, we did that point survey at 360 degrees, looking around us. And we made subjective judgments, okay, on 5 major factors that, in our opinion, affected the environmental quality. So we looked at noise pollution, litter, the amount of greenery, the amount of air pollution, and the facilities, so things like benches, bins, street lighting, CCTV cameras, etc. And we judged these on a score from -3 to +3. Now, the justification behind this is that we picked these 5 because after discussions before going into the field, as a department, we felt that these were the most significant impacts on environmental quality. And the sort of geographical theory behind this is that if environmental quality is higher, it would indicate a successful urban regeneration. Environmental quality, when it's higher, generally attracts more visitors, which will mean more customers in the area, increase in income. And again, that point survey done due to time constraints in regards to time. So moving on to the presentation of our data, again, you're not necessarily going to be asked here, because in this paper it's not really about what you did or describing what you did, it's about justifying or assessing the validity of what you did. So looking at the data presentation for our pedestrian count, what we did was a located proportional diagram. So if you remember, we had a base map of Woburn Town Centre, the regenerated area and the non-regenerated area, and then what we did was we drew proportional diagrams, stick figures of people, okay, their height depending on how many people counted, and their width depending on how long we counted for. Now, the major positives of this was it was easily relatable. The stick figures indicate people, so looking straight at it, you could assume just from the way we presented the data, even without a title, that we were counting pedestrians. Okay? It's also doubly proportional, as I said, so the height was relevant to how many people we counted, and the width to how long we counted. So it was 2 centimetres wide, because 1 centimetre equaled 5 people. So 5 minutes of counting, and for every 1 centimetre up, it was 20 people counted. That allowed for a very easy and visual comparison of the number of pedestrians in the regenerated area versus the non-regenerated area. Also, the fact that it was located meant that people would be able to repeat our study in exactly the same location. So we could actually see that spatial pattern of the data. We could actually see that the regenerated area had a significantly higher number of pedestrians versus the non-regenerated area. Negatives of the strategy. So again, if you ask to what extent was it effective, to what extent was it valid, there was limited accuracy. If 1 centimetre was 20 people, considering the high number of people we're counting and the fact that generally we weren't obviously getting numbers that were multiples of 20, did mean that maybe accuracy was limited. Also, on top of that, it doesn't show the direction at which people were walking. It may have been that people were walking through the regenerated area to access the non-regenerated area, or vice versa. People moving through the regenerated area into the town centre that's been regenerated. So actually these customers may not have actually been using the non-regenerated area. You may get asked about alternative ways of presenting this data. We could have done a pie chart, just looking at the percentage of people that we counted over the whole day in the regenerated area and the non-regenerated area. What could have been quite nice as well was use proportional arrows. The arrows again could have shown the width of how long we counted for, their height could have represented how many people, or their length, represented how many people we counted, and the direction in which they were pointing would have shown us the major flow direction of people. So we would have been able to tell if people were walking through that non-regenerated area into the regenerated area, or from the regenerated area into the non-regenerated area. In terms of the shop type count data presentation, we use 2 pie charts. So pie chart showing us the percentage of type of each category of shop in both the regenerated area and the non-regenerated area. Massive positives of this, is that it shows the variety of shops present. It shows the percentage of shop type present. So there's no need for the same number of shops to be counted. So it didn't matter that maybe in the regenerated area we only counted 20 shops, and in the non-regenerated area we only counted 10. Because it then works them out as a percentage, it allowed for a really good comparison. And it allowed us to see which type of shop had the major, that dominated the shop type count in both areas. There are certain issues though with it. We drew these by hand, so there was low accuracy. And again, like overall pie charts, they don't show the exact number of shop types counted. So while this could be viewed as an advantage, it doesn't, it does mean that your sort of data presentation could be skewed, because if you've only got a very small sample size, so for example, if you've only counted 4 shops and 2 of those were comparison shops, that's going to make it look like 50% of the shops you counted were comparison, which it was, but it doesn't really indicate how small the sample size is. Alternative strategies that we could use: compound bar charts, so pretty much a pie chart, but kind of in a bar. So each sort of a stacked bar chart, if you can imagine that. So you've got, for example, your bar here, and then you'd have, this many were comparison stores, that many were convenience, and so on. And another nice way, in this way of kind of improving on the pie chart, would have been to have a proportional pie chart. So the radius of the pie chart was relevant to how many shops we counted. So for example, for every half a centimetre the pie chart was wide, that would have indicated 1 shop counted. That would have then allow us to tell if we counted more shops in the regenerated area versus the non-regenerated area, which would have given us a kind of an extra layer to our data. The final data presentation that we needed to look at was the environmental quality. So what we did here was we looked at what we call a located bipolar graph. So we had our graph measuring axis 0 to 3 and to -3. And then what we did is we had bars showing what the scores were in the regenerated areas and what the scores were in the non-regenerated areas. Now the massive sort of positive of this, it's really easy to compare the 2 areas because they're on the same scale. So you can very clearly start to see where one area is scoring better than the other. On top of that, it shows us how each category affects the total score. We could have just done a bar chart showing the total environmental score, but this actually shows us how things, for example, like noise or litter, affected that overall score. Also, what we did is we worked out things like the mean score. So we calculated what the mean score was for each area, and we drew that onto our graph. That's, adds a complexity, a kind of higher level of data to our presentation. Also reduces the chances of anomalies affecting our data. And if we return to our proportional diagrams, the bar charts were located onto the same maps. So again, it shows somebody where we collected the data so that they could then go and repeat the count in exactly the same place. And on top of that, it means that we can see that spatial pattern. We can see kind of the data located to where it was collected. The negatives of it, okay, is very minimal actually. It's a really good way of presenting data. The only thing is, and it kind of should be mentioned here as well, is that the map that we use, the scale means that it's quite difficult to accurately locate the exact point on which we were standing. Alternative strategies for presenting this, we could have used a radar graph, okay, which would have done a very, very similar thing. If we move on to look at the results and conclusions, now in the exam what you might get asked about is a question along the lines of to what extent do the results of your investigation allow you to draw reliable conclusions, or to what extent were the results useful in allowing you to answer your original question, okay, your hypothesis. So if we have a quick little look, we don't really need to know loads of information. It's not a test of how much of your data can you remember, but at the same time, some little key facts and figures could be quite useful. So for example, using the data that I collected, and you could repeat this in the exam. The examiner's not going to know if it's your data or the data that I collected that you're talking about. It's, you've been out there, you've done the field work, so you may have your own data, but just from the data that I'd collected, what we saw was that we had over 40 people in the regenerated area. Okay, so 40 more pedestrians counted in the same 10-minute spell. Okay, the environmental quality, again, not needing to remember all of it, but maybe a little bit sort of data about the mean score, that in the regenerated area we had a score of +1 overall, and in the non-regenerated area of -0.8. Shop type count, for example, there was 30% of the shops in the regenerated area were comparison stores, and 15% were comparison in the non-regenerated area, showing a higher percentage of comparison stores, which we know to be higher goods shops in the regenerated area. So, what does that actually allow us to tell those results? Well, it suggests to us that the overall results are indicative of a successful regeneration. Higher pedestrian counts indicate a higher footfall, and therefore the areas must be more attractive. Okay, it therefore has more customers, increasing the income. The environmental quality links into that. A higher environmental quality, again, is normally an indicator of successful regeneration. It means that the area is more attractive to people to come to, which we will therefore, as I've said, increase footfall and customer numbers. And the shop type count shows that obviously large chain stores and high order comparison shops feel it's necessary to locate into the regenerated area due to the fact that it's a more successful area for them to do so. What you must remember, however, the question is to what extent. So we need to consider the other side. And it's this idea of the building blocks. There were problems with our methods. That means there were problems with our results, which means that our conclusions are weaker than they could be. That we have to question the validity or the strength of our conclusion. So if we had that exam question, to what extent do our results allow us to draw reliable conclusions, or to what extent do our results allow us to answer the original question, we can definitely say yes, there is an indication, and a strong indication, that the regeneration has been successful. However, our conclusions are maybe not as strong as they could be. They're weakened by certain problems or limitations with our methodology. So if we want to look at those problems and limitations in a bit more detail, let's start off by looking at the pedestrian count. Okay, and when we think about our problems and limitations, okay, this is like your evaluation of what you did. Okay, looking back on it, you can really consider the problems and limitations in two categories: accuracy or reliability. It is actually vitally important that you understand the difference between accuracy and reliability, because it may be in the exam the question will ask you about problems regarding the accuracy of the data or problems regarding the reliability. And if you get the two confused and you start giving problems that actually relate to accuracy, not reliability, you may lose marks. So for example, one of the problems or limitations of our pedestrian count for accuracy was the possibility of miscounting people. Okay, when large groups walk past you, it may be difficult to count the number of people going. When you're looking down to tally on your bit of paper, it's possible that somebody would have walked past very quickly, or somebody may have walked behind you and you may not have actually counted them. Okay, this is probably going to cause minor sort of inaccuracies in the data, but they are still inaccuracies. The reliability is more about how representative is the data you've collected of normal conditions or the whole population. And again, we do have a bit of a concern here. Okay, we only counted for 10 minutes of the day. Okay, that actually only means that we counted for 0.07% of a day. Therefore, our sample size is very, very small, and it may not represent normal pedestrian counts in both the regenerated area and non-regenerated area. At the same time, we did them at different times in the day. Obviously, we couldn't be in two places at once. So we did the count in the regenerated area closer to rush hour than the non-regenerated area. Again, that may affect the reliability of the data collected. On top of that, okay, you've got, if you're only doing a 10-minute count, you've only got small samples, you've got a much higher chance of anomalies affecting your data. So for example, if you did your 10-minute count just as a large double-decker bus pulled into the regenerated area and people got off of it, the pedestrian count's going to go up. In terms of improving our pedestrian count, there are a few things we could do. To improve the reliability, obviously we could try and increase the sample size. So this may involve counting for longer than 10 minutes so that our data is likely to be more representative of normal conditions, okay? Or repeating the count, so doing the count several times during the day, at different days of the week, different times of the year. Again, this means that our sample size is going to be larger and it's going to be more representative of normal pedestrian counts in the two areas. What we could then do from that, if we've got lots of counts, we've repeated it, we could work out an average, okay, which would reduce the impact that any anomalous data, as I said, by like a large bus load or train coming in, okay, or market day or something like that, affecting the pedestrian counts. To improve the accuracy, what we could do is we could use a clicker or a video to record pedestrians. So a clicker, you know, one of those things that sort of doormen have on bars and stuff like that, where they click to every time somebody walks past them. This means that you don't need to look down. Or you could use a video recording. You could slow it down and watch it back after the event to ensure that you didn't miss anybody. All of these improvements, and we're going to talk about this in a bit, are obviously going to improve the reliability of your conclusions. So it's this building block structure. If you make your methods better, your data is better, therefore your conclusions are going to be stronger. They're going to be based on more representative, more accurate data. So going on to the Shocktide Cam. Accuracy problems, possibility of misclassifying shops, particularly shops that had multiple uses. So department stores, where did you put them in? Okay, there may have been some shops that actually had an appearance on the front that actually wasn't what they did. And you know, thinking straight away in Worthing, you've got the Rocking Horse cocktail bar that some of you may have counted from your position. Okay, from the outside, it actually looks like a kind of toy shop or sewing shop with lots of rocking horses in it and lots of kind of drapery. Okay, it's actually an eatery. Okay. You may miss smaller shops, okay, so shops maybe on the second floor, ones in the basement and so on like that. You know, these shops may not have been counted as you looked around your 360-degree point survey. Again, reliability comes down to the small sample size. You only did 1 point sample in the two areas. That means that you are going to only be collecting data from a very small section of the regenerated and non-regenerated area. One of the other possibilities in terms of reliability is there's a high chance of bias. As we said, one of the good things about the area was that it was familiar to you. It reduced the risk. However, that does mean that there was a chance of choosing a place to do the point survey that was going to particularly show the non-regenerated up poorly and the regenerated area well. So how could we improve on this? In terms of improving the accuracy, we could have got secondary data. Now remember, secondary data is data that you haven't collected yourself, so it's from another source. The council, for example, will have a land use map and a list of all the shops in the two areas. Therefore, you would have got a very accurate and up-to-date knowledge of all the shops in the area. You could have also done a transect survey. So this is moving away from that point survey where you're only doing your count in one location. You could have walked through the two areas, counting all the shops that you see on a certain set route. Okay? This means that your data or your sample size is going to be bigger. It's more likely to represent the whole population. Finally then, we've got the improvements or limitations to the environmental quality survey. Now here you've got a bit of a combination of accuracy and reliability problems. Okay? It was highly subjective. Okay? We scored it based on what we thought. So you stood there, you guys made a decision on whether or not you thought it was -3 or +3 or anywhere in between for those 5 categories. Okay? That means that what I think is +3 may be different to what you consider as +3. So you've got a high lot of opinion in there. Okay? Therefore, as soon as you start bringing an opinion, you're bringing in bias, because if you've got an opinion of the regenerated area versus the non-regenerated area, that is likely to influence your results. And again, we only did a very small point survey. Okay, so when you studied the area, we were making judgments about the environmental quality of the entire regenerated and non-regenerated area simply based on doing an environmental quality survey in 1 point in each. Okay, so what we could have done to improve this, in terms of improving the accuracy, we could have used equipment such as decibel meters or air pollution readers that would have given us a digital reading of noise or air pollution, which is obviously much less subjective, much more accurate, less likely to be affected by bias. Or we could have done, again, a transect survey, so doing maybe lots of environmental quality surveys, okay, along a line. So going along a line, maybe 1 kilometre long, doing an environmental quality survey every 200 metres along that line, and then working out an average. This would give us a much larger population from our sample. It's more likely to represent the environmental quality of the whole area and to be less affected by anomalies, because we could then work out a mean environmental quality for the whole area, which means that any anomalous readings, maybe because 1 point had just been cleaned, for example, or for some reason the road was shut at that exact point, is unlikely to be as significant in terms of affecting the results. So what the question here is likely to ask you is, evaluate your methods, or evaluate how improvements to your methods could affect your conclusions. And it's that understanding that your conclusions, that building block, your conclusions, if they're based on more reliable and more accurate data collected through more reliable and accurate methods, your conclusions are going to be stronger.